Good afternoon, everyone. Thank you for the invitation to speak, and thank you particularly for Bill. I'm now slightly worried because that conversation ended with the observation that we're getting into too much detail. I'm going to take conservation management through experiments, but I'll do it anyway. Just before I start, I'm going to huge thanks to a range of colleagues, all listed here, who've really led some of the experimental work in conservation management that I'm going to talk about. A bit like Craig did, a very little bit of background to the Royal Society for Protection of Birds, the RSPB. It's been around since the late 19th century. It's a big conservation NGO, about 150 million annual turnover as a single organisation, just over 1 million supporters, 18,000 volunteers, about 2,000 staff. We are the UK partner in BirdLife International and a founding partner here of CCR. Relevant to today, I think, is our network of nature reserves. Not so many compared to the Wildlife Trust, only just over 200, but they do cover 140,000 hectares and a big UK spread. And the fact that, well, as I'm about to say, throughout my lifetime, at least, RSPB has maintained a pretty fundamentally evidence-based approach to our conservation. And at the moment, I'm very proud to lead a team of about 50 or 60 scientists, and we spend between core resources and resources we bring in from grants and contracts about £5 million a year. That's about 5% of our total conservation spend. Interestingly, I think 5% is also the figure that definitely heard. I talked about the deep roots of evidence-based approaches in RSPB, and so I just wanted to take a moment to mention this gentleman, James Cadbury. James was, as far as I can work out, the second head of science in RSPB. The first one, I think, was in 1964. So the RSPB's had a head of science for as long as I've been alive. James Cadbury was the second. He started work in 1969. He died very recently at his home in Cambridge and was an absolutely wonderful scientist and conservationist. And as you can tell here, was a bit of an expert in the botany and conservation of the Seychelles. But the reason I mentioned him today is that others of my colleagues unearthed this amazing archive document, which is the RSPB Wardens Conference agenda from the 26th to the 30th of October. No, 28th to 30th. They spent 3 days with their Wardens Conference in 1969, and James, possibly one of his first speaking engagements in his new role of head of science, was talking about the role of wardens, which read reserves, and the place of reserves in the research programme, which is exactly what I'm doing 50 plus years later. So our roots in this business go quite deep. Why should we care about experiments? Well, I can do no better, really, than refer to the book. The book, I think we call it the book now, can't we? Two quotes here from chapter 10 of the book. Why should we care about experiments? Well, a big advantage of embedding experimental designs into conservation projects is the potential to improve future management, adaptive management, learning by doing. And experimental tests, where they're feasible, are usually the best way of generating the best quality evidence for the effectiveness of actions. And that's what Alec was talking about earlier. And a bit like Alec mentioned, the examples I'm going to give you cover that range of, hopefully, the ones that Alec had a bit further up the y-axis than just doing something and then monitoring what happens afterwards. Slightly more formally experimental comparisons with replications, controls, elements of before, after, or spatial comparison. Now, experimental work in RSPB across our nature reserve network is both natural science and social science. I don't have time to cover all of it today, so I'm going to give some natural science examples. The first three are all a kind of packaged together, illustrative examples of experiments focused around wader conservation, or shorebird conservation, if you prefer. Breeding wader conservation is a major conservation challenge globally, and especially in Europe and in the UK, because we've had long-term declines in populations of species driven by intensive wider countryside management. And for many of these waders in the UK, nature reserves are therefore an increasingly critical refuge for their remaining populations. So therefore, they become a natural focus, both in terms of conservation priority and questions about the best way to manage them. I'll then move to the other end of the UK, talk about an example from the flow country in Scotland, and then briefly talk about a couple of examples of ongoing studies which have yet to report. But first of all, shorebirds, wader conservation. As I mentioned, breeding wader populations are heavily constrained by intensive land management. This means that we've now got increasingly concentrated remaining populations on our nature reserve networks. That includes species like lapwing here, curlew, redshank, and so on. And whilst one can engage in high quality habitat management for these species, focusing on vegetation structure, soil condition, hydrology, the fact that these nature reserves tend to be isolated in seas of more inimical habitat means that these ground nesting birds also suffer from high predation pressure. That therefore becomes a very direct and immediate conservation. How do you address that? Do you address it by lethal control of predators? So in the case of some mammalian predators like foxes, for example, lethal control is possible, but it's expensive and it's not particularly ethically done. And of course, there is also avian. So these concerns led some years ago now to an experimental study to formally test whether instead of relying on lethal control of predators, it was possible to exclude them from the critical areas on the nature reserves where the breeding waders are nesting. So in this case, this was a predator exclusion fencing. It was carried out across 10 nature reserves across the RSPB network, which are lowland wet grassland reserves with high populations of breeding waders. The focal species in this case was lapwing. And essentially, we were talking here about either electrified stock fencing or a kind of simpler electric fence. Could be either or both of those designs, based on the left here. And the study here basically involved replicated fields with or without fencing across these 10 reserves, looking at the breeding performance of the waders within and outside the fences and before and afterwards. And the critical result after several years of this experiment was that essentially, once you implement the fencing and look at the performance of the breeding waders across the reserve, once fences are implemented, in this case, you raise lapwing productivity from about 0.25 chicks flesh per pair up to 0.8. And this band here at the top of the graph is the range that other studies suggest you need to do for sustaining population of lapwings. So this experiment, published here in Journal of Nature Conservation, demonstrated the effectiveness of the technique, and it's now being rolled out across a much greater number of RSPB reserves, thus greatly reducing any need for reliance on lethal predator control of mammals in this case. As I mentioned, that doesn't entirely solve the problem because fencing doesn't keep birds out. And some of the predation pressure does come from birds. It can come from corvids and occasionally also raptors. And this, of course, is something of an irony because here at the reserve in question, which is the Otmore Reserve in Oxfordshire, the issue here is that the predation is being caused by recovering populations of red kites, which in themselves are a high conservation priority. So what's happening here is that you have Otmore as a single nature reserve, but very high quality for breeding waders, set in a landscape which now has almost no waders, and it's essentially a honeypot for predators, drawing them in from the surrounding landscape. In this case, the experimental test was diversionary feeding. So this is already a site that has the exclusion fencing. So we already had that in place. In this case, the experimental test was to ask the question whether diversionary feeding the kites with carrion successfully dissuaded the birds from bothering to seek out wader chicks and could therefore result in sufficiently high breeding productivity of the birds. Again, the focal species was lapwing. And you can see here in terms of lapwing productivity and rate of strike of the ret kites on the lapwing chicks. In the years when there was diversionary feeding in place here in 2015 and 16, there were much lower strike rates of the ret kites. They were taking the diversionary food. And again, the productivity of the lapwings in those 2 years was much higher and well into the range required for populations. So again, in this case, a very site-specific problem and a site-specific experiment and solution, but very effective. And I mentioned that wader conservation isn't just about controlling predators. It involves a great deal of habitat management, creating suitable grassland sward conditions, suitable hydrology, suitable soil conditions. So there's a package of measures applied for lowland wader conservation across all of our network of reserves and indeed those of other organisations. And in this case, and I think in Alec's typology this would count as an experiment. What we did here with a brilliant student, Sean Jellesmar, is look at the long-term trend of waders across all RSPB lowland wetland grassland reserves that are managed for waders. That's the green line, and compare that. That's about 47 reserves, and compare that with a counterfactual which is the trends of waders in the wider countryside as represented by the Breeding Bird Survey. So this is the citizen science survey run by the British Trust for Ornithology. So this is a great use of citizen science data to give us the broader picture against which we can test the performance of the birds on the nature reserve network. And the BBS data was subsampled to pick out those sites which provided a good counterfactual comparison with the RSPB reserves. So in other words, they had to have the data over the same time period, be in the right elevation band and contain similar basic habitats. And you can see here that for no less than 4 wader species, curlew, lapwing, redshank, and to a lesser extent snipe, there's good evidence here that the whole package of wader conservation is delivering beneficial outcomes as a whole. And interestingly, a kind of control species here, yellow wagtail, which is another grassland species, but not the target of these measures, not evidence of benefit. So interesting example here that perhaps you lose focus on other species that are important too, if you're not careful. So those are my wader examples. And thanks also here to Natural England, who helped to fund the diversionary feeding work I mentioned in the previous slide. Okay, let's move to the north of Scotland. This is the Flow Country, a huge landscape scale expanse of blanket bog in the far north of Scotland, in Caithness and Sutherland, which, fingers crossed, may soon become a World Heritage Site. Don't know whether we know anything more about that, Clive, do we? But fingers crossed anyway. A vast landscape in which RSPB is very fortunate to own and manage 21,000 hectares as our Forsyth Flows Nature Reserve, also a National Nature Reserve. And here's an example of a study on, well, this is the common scoter, but it isn't common if you're in this country. Very closely related to the North American black scoter, highly endangered in the UK. Most of its small remaining population is on these peatland lochs, where it has been declining. And so this is, I think, a really neat small-scale experiment, which was based on some initial correlative work. The correlative work established that the common scoters, in terms of which lochs in this huge landscape complex of water bodies they used, prefer to use their diving ducks, but they prefer to feed in relatively shallow water that is rich in invertebrates and has fewer trout, brown trout in the loch. The brown trout have historically been introduced by angling interests. So the question arose from that initial correlative work, and thanks here to WWT and Nature Scott for supporting some of this earlier work and indeed on into the experimental phase that I'm going to talk about now. The question came, well, those historical introductions of brown trout, are they responsible for the reductions in invertebrate populations, the invertebrates being the critical food for the nesting common scoters? So this, you can only do this on a fairly small scale. So 4 lochs, one control, and then 3 others. And on those, a combination of either simple wire exclosures to keep the fish out of particular areas on the loch, angling and removal of the fish to reduce brown trout populations, or both. And those treatments undertaken across a few years with before and after data and comparisons of the control loch. And again, very briefly, but what do we find over a period of 3 or 4 years? Well, the exclosures increased invertebrate biomass by nearly 5-fold, including taxa of relevance for common scoter foraging. The angling intervention reduced trout biomass by just over half. And when we followed this up by examining how birds were using these lochs following the experimental interventions, the complex an assemblage of 5 species, including common scoter, but 4 others as well. I think that was greenshank, dunnelin, mallard, and teal. Again, increased about 5-fold. So strong suggestions here that brown trout were playing a part in suppressing the invertebrate populations, could be playing a key part in driving common scoter declines. And we've now started to put longer-term angling agreements in place on key lochs to keep this management going. Okay, just going to mention 2 other examples of ongoing work. Then I'll stay in the Flow Country for the first one. This is on a huge scale. This is the same landscape, the Flow Country landscape. And on this picture, you can see huge areas of ground, which until recently looked like the little triangle on the right. In other words, they were non-native conifer plantation, put in under tax incentives in the 70s and 80s, generally not forestry that's performed very well on the deep peat and isn't particularly profitable. And now, of course, a strong incentive in the interests of carbon conservation and blanket bog restoration to bring these bogs back to life, to restore and a huge investment over many years in that bog restoration process. But that's a complicated process, because when you harvest the trees, you are left with what was formerly a flat bog surface. You've now got essentially a ridge and furrow situation, because the bog was ploughed for the trees to be planted. So you've now got high ground, low ground, high ground, low ground in ridge and furrow alternation. You've also got to ask questions about, well, what do you do with the brash once you've taken the poles out, the timber out? What about the brash? How do you manage that? There are drainage channels around and within the plots where the trees were planted. And all of these provide challenges to restoration. So across this whole landscape, this is now a kind of patchwork of experimental treatments, comparing different post-harvesting treatments. So how the brash is managed, to what extent the furrows are blocked, whether there is blocking of drainage systems around the edge of the blocks, and also bulk surface treatment. So in other words, that's literally kind of cross-tracking the surface to reflatten it and remove the ridge furrow structure. All of these are expensive things to do, so the balance of benefit against cost is important to understand. And so we have a replicated experimental work still ongoing, outcomes including biodiversity, birds and invertebrates, greenhouse gases, and so on, and hydrological responses, water saving. And this is a huge program of work with many collaborators across multiple universities. More on that when it reports in due course. And then lastly, this is very new. We've only just started this year. RSPB board and trustees recently agreed that we should seek to massively reduce our herbicide use on our estate, at least by 50%, ideally much more than that. And a major use of herbicides on our estate currently is, and it goes back to the wader examples that I used earlier, it's managing infestations of soft rush on fields that are important for waders, because if you get excessive soft rush infestation, it renders the fields unsuitable for most waders. So historically, we've used herbicides. So this experiment, again, it's across 12 reserves, 12 RSPB reserves and a couple of wildlife trust reserves as well. So thank you, Craig, for that. And comparing impacts of alternative cutting and grazing treatments as alternatives to using herbicides. We've just started that. The program will run for a few years to come. Okay. I think other speakers before me have essentially covered everything I was going to say here. But from those examples, and it is a tiny selection of the experimental studies I could have talked about, I just wanted to reflect on the fact that people in the organisation and in many other organisations and their working relations, it's critical for all of these experiments to have happened and to have happened successfully. Mark Hancock recently retired, was a senior conservation scientist in my team, and brilliant at bringing people together to design and implement these experiments, often at scale. Here he is, taking a sediment grab in a flow country loch. And here are Danny Klein, restoration manager in the flows, and Neil Cowie, one of our principal ecologists. And their established long-term working relationships and trust developed over a long period of time were critical, really, for these experiments to happen. And I would love to say that in the culture of the RSPB, I could point to these examples everywhere in the organisation, but I can't, in all honesty. This is really challenging to achieve, let alone the resource needs of running these experiments. But I wouldn't, I still think there's work to do to get this quality of working relationship between conservation scientists and practitioners. And boy, does it make a difference having them under the same roof in the same organisation working together. But even so, embedding this culture more broadly across the organisation remains a challenge for the organisation and for me personally. But without them and without colleagues like them, we couldn't have done any of these experiments and many more I haven't had a chance to mention. Perhaps the last thing I'll say, and I was really struck by the way Harriet and Catherine were talking about the formal embedding of evidence-based approaches in corporate strategy. I'm not sure we quite do that in the RSPB, and I think the reason for that might be that our evidence-based approach does run so deep, and we are so used as an organisation to being evidence-based in our approach that it is almost taken for granted. And maybe I've learned something from today, which is that perhaps we need to be more explicit as an organisation at strategy level. We do this, but we should say we do it more explicitly at strategic level than we currently do. Thank you for listening.
so much. Sorry, if we want to go to break, we don't really have time for any questions, and I think we've got a really quick one. Yes.
Thank you. Jeff Hilton from WWT. Thanks very much, Jerry. A couple of sort of commenty, questiony things.
Yeah.
On this business of practitioner-scientist relationships, I think it's a really, really good point you make. And if I had £1 for every time I've heard practitioners saying we don't have time to wait for the science, I would be need to bet on the date of the general election. And it's a really, I mean, it's a comment that drives the scientists nuts, because we're kind of arguing we're not telling you to wait, we're telling you to do so we can study the doing. But I'm interested in, you know, your kind of understanding of that argument and what is the solution, because the scientists are often perceived as the barrier to progress, and that mutual understanding of how we work is often missing, right?
I have experienced that in the RSPB historically. And in fact, I was having a conversation on exactly this topic at lunchtime, which is that we are all, whichever of the conservation NGOs we work with, we're all working for organisations that want to do. We're facing a biodiversity emergency for good. And I think that can result in a potential challenge to evidence-based approaches and a potential challenge to scientists within organisation. I mean, I have heard the phrase used once or twice, paralysis by analysis. Are we causing that in organisations? I genuinely don't think we are. And to my mind, an awful lot of the kind of science we're talking about is basically just putting a little bit of a structured framework around the doing, around the intervention, so that we learn from it quickly, efficiently and effectively, and can improve outcomes in the future. And if we've got stories like I hope some of these were examples of, where we've demonstrably changed conservation practice for the organisation, or more broadly through the use of these sorts of approaches, then we've got a pretty strong case to make. I genuinely don't think very often. We should always be attentive to the possibility that we are slowing down action, but I think in most cases we're not, and we're not going from accelerator to brake. We're going from accelerator to steering wheel and making sure we're going in the right direction. That's the argument I would make and do make in turn.
Okay, so it is break time. I'm just looking